Alright, so welcome to my first video lecture. Today I'm going to talk about scientific notation. First thing to get out of the way, I don't think you're going to see me dressed so casually in any of these other lectures, but it's still summertime and it's quite warm in this building. It's like a sauna in here. So I apologize for that. We're going to talk about scientific notation. And here's our I can statement. I can rewrite a number into scientific notation. So now, here's the reason why we do this. In science, we have some really big numbers that we use often, and we have some really small numbers that we use often. And I'm going to show you a couple different examples in this lecture of a big number and a small number. But it's really inconvenient to have to write out a number that has, let's say, 23 zeros at the end of it. So scientific notation is going to let us do that more conveniently. I want you to take a moment, write this down. I wrote down scientific notation. What it does, it takes a big number or a small number and rewrites it in a more convenient form using multiples of 10. I'm going to leave this here for a moment to give you a chance to write it down, but I need you to realize that we're going to rewrite this number. It's the same number, but it's just going to be more convenient for us to write it and more convenient for us to compare it. So let me give you an example, first of all, of a big number. Now, I hope I'm pronouncing this guy's name right, but Olaf Romer, he was an astronomer, a Danish astronomer around 1600s, and he was the first scientist that attempted to calculate the speed of light. Before Mr. Romer here, they all thought light was so fast it'd be impossible to calculate how fast it traveled. But he was the first person to attempt to do that, and he came up with this value here. His value ended up being around 214 million meters per second. So that's 214 with 6 zeros at the end of it. Okay, a lot of zeros at the end of it. Great if that's dollars in our pockets if we win the lottery, but not so good if we have to write this down in a science paper. So what we're going to do is I'm going to show you a series of steps to take this and write it into a more convenient form. So what I want you to do is I want you to write these steps down with me, and we're going to take this number each step and we're going to show you what you have to do to rewrite it into proper scientific notation. Okay, so step number 1. We are going to place a decimal point between the first and second number in this whole big number here. So what we're going to do is we're going to place a decimal between the 2 and the 1. If you want to be technical, the decimal has to go just to the right of the first non-zero. We're just going to write this down. Place a decimal between the first and second number. So let's go ahead. We're going to do a decimal between the 2 and the 1. Okay. We're going to write the 4, but in step 2, I'm going to tell you now, don't write down any of these trailing zeros. We're not going to write down any of the zeros at the end of the numbers, and if you have zeros at the beginning of a number, we're not going to write those down either. And I'll give you an example of that. So let's do step 2. not write down beginning zeros or ending zeros. So do not write down beginning zeros or ending zeros, comma, because what we do have to write down, we're going to write down times 10 to the, because this does multiples of 10. So now we have, after step 2, 2.14, decimal just to the right of the first non-zero, times 10. All right, now for step 3, what we have to do is we have to figure out, okay, where did our decimal start? Where was it before we placed it? And where was it after we placed it? How many spaces we had to move that decimal? Here, let me show you. It might be easier if I show you. Now you look at this number, 214 million, and you don't have a decimal, but hopefully your math teachers taught you. You don't see a decimal in a number, you're going to assume it's all the way over there to the left. Or actually to the right. If I can get my marker cap off. We're going to assume it's right there. So let's see, right here it starts. Right here is where we place it. So count over how many spaces? 1 space, 2 space, 3 space, 4 space, 5, 6, 7, 8. So we moved that decimal 8 spaces. So step 3, count how many spaces you moved the decimal place. And what that gives us now, that gives us our exponent. Okay? And what the exponent is how many multiples of 10 we moved our decimal point over. So we moved it once, twice, 3, 4, 5, 6, 7, 8. We're going to make that our exponent. And our exponent is just a small superscript right behind the times 10. So this right here, we're finished with this number, 2.14 times 10 to the 8th. This right here is the exact same value as this 214 million. We just took this big number with 6 zeros at the end of it, and we rewrote it to 2.14 times 10 to the 8th, and it tells us that we have 8 zeros. Okay. Well, actually, we moved it 8 places to get our decimal right there. Fortunately, I have to add one more step here because it doesn't quite cover all instances of when you're going to have to use scientific notation. Now, step number 4 is going to help us between big numbers and small numbers. We moved our decimal place over to the left here because we took a big number and we made it into something smaller with exponents at the end of it. So follow me here, step 4. We're going to write down, if decimal was moved to the left, that means we have a positive exponent. So we don't have to do a plus sign right beside this 8. We're just going to leave it just how it is. So the final answer is 2.14 times 10 to the 8ths. We just rewrote 214 million into 2.14 times 10 to the 8th. Now, this is the rule if it's a big number. I'm going to write that in parentheses here. For a small number, for step 4, if decimal moves to the right, if we moved our decimal to the right, then we're going to have a negative exponent. And let me show you an example now of when we would use this. What I wrote down here is the diameter of a hydrogen atom is approximately 0.000000000, that's 9 zeros, and then 106 meters. We'd hate to have to write this down a bunch of times, so let's use scientific notation, rewrite it in a more convenient form using multiples of 10. So step 1 here, okay, we got a decimal here, but it's not to the right of the first non-zero. Our first non-zero is way over here, this 1. So we need to put a decimal right here between the 1 and that 0. So we're going to rewrite it. We're going to rewrite 1.06. Step 2, Do not write any of the beginning zeros or ending zeros, and in this case I have beginning zeros, so I have all these that I don't have to write, but I do have to write times 10. Next thing we got to do is we have to count how many places our decimal moved. Okay? This time it's easy to see where that decimal started. It started here, and we moved it once, twice, 3, 4, 5, 6, 7, 8, 9, and 10. Okay? That's our exponent, our 10. So after step 3, we have 1.06 times 10 to the 10. Okay? But we got one more thing to take into account. We don't have a big number this time. We have a small number less than 1. So anytime you move that decimal to the right, it means you have a small number. And our exponent is going to be negative. So to finish this up, we have 1.06 times 10 to the negative 10. And now to be good scientists, the last thing we need our units. This one here is meters. And the one up here I forgot to do. Meters per second. So just a couple key points that I want to give you here that I've seen student mistakes in the past. First of all, step 1, putting that decimal in the correct location. Okay? To be in proper scientific notation, has to go just to the right of the first non-zero. So we could have placed the decimal anywhere in here and counted how many over spots we moved, and we wouldn't have a wrong answer. But it wouldn't be into scientific notation. Okay? And it's very important that we're consistent, and we want it just to the right of the first non-zero. I think to myself between the first and second number. That's just how I think. And then next piece of advice I give you, if you have a big number here, like Romer's, it's going to be a positive exponent. We had to move that exponent. It was over here way on the right. We're going to move it over to the left. Okay. Really small number, less than 1. We moved our exponent to the right, negative exponent. So what I'm going to do is I'm going to give you a couple practice problems here that I want you to bring in tomorrow. This is going to be a ticket in the door. Now please just write it on a small piece of scrap paper, these two problems that I'm going to have you do. And I'm going to stand by my door tomorrow, hand out, you're going to put it right in my hand, and then I'll let you into my classroom. So let me grab my thing. Okay. So first ticket in the door problem is $15 million. We're going to say 15 million degrees Celsius. That's the temperature of the core of the sun. I want you to take this big number, rewrite it using proper scientific notation. Second problem I want you to do is I want you to take this number this is 0 point, and then you have 400,000,158 miles. That's how many miles are in an inch, and I want you to rewrite that using proper scientific notation. So please bring this ticket in the door, and please also bring these steps with you to class so we can practice just a little bit more and I can hopefully answer any questions. Appreciate your patience in watching this first attempt at doing a video lecture. I'm sure I'm going to get a lot better at it as we go throughout the year.